Hello, everybody, and welcome to the DevEd podcast. I'm your host, Joe Eames. Today on our panel, we have Luis Hernandez.
Hola.
Mike Dane.
Hey.
Sam Julien.
Hey.
And as a special guest today, we got Tommy Williams.
Hello.
Tommy, could you want to give us a little bit of an introduction to who you are and your background?
Absolutely. So currently I work at a small advertising company, Playware Media. .com as a software manager. Essentially, the project I work on day to day is your YouTube player competitor, where we just ingest ads, and I'm making it sound simple. It's very complicated. Along the way, though, I've been, we're kind of a small, medium-sized company, but along the way, I've pretty much done it all. Started coding when I was a kid, so it was no surprise to me in college what I wanted to do. I always knew, starting 10 years old, I wanted to be a hacker. Since the movie Hackers came out, and really got into learning to be a hacker. You had to know how to code and create the code yourself. And then eventually I went into web development because the web blew up there with JavaScript, and I just wanted to be the best at everything. And eventually got to college, found out I didn't do so good in high school. So it took me a little longer than most folks, but got my degree, and I've worked from the smallest of small startups to the largest corporations such as Office Depot. So finally found my niche here and a place where I can really make an impact.
Awesome. So our topic today is learning performance testing, which is kind of an interesting topic. I will admit right off the bat that I do not consider myself to be much of an expert in performance tuning in general. And so I'm actually really interested to kind of see where the discussion today goes, because learning how to performance tune is definitely something that I have had on my mind quite often. I always feel like, boy, I really wish I could get in there and figure this out or make this better or that sort of thing. And obviously there's some basic stuff, but there's a lot. I mean, performance tuning is really a big, complex topic. So I'd like to kind of get us started really with sort of a definition of what performance tuning really means. I know we got Tommy, we brought you on as sort of our resident expert, but we'll kind of open this up to really everybody. Maybe we'll start with Tommy, but if anybody else after that wants to chip in, but maybe if you could spend a minute, Tommy, and sort of talk about what does it really mean to performance tune?
Sure. So, I mean, pretty much any company aside from a startup that you join onto, you're the new guy. There's already code there that's been written, and you look at that code and you're like, who wrote this? What schmuck wrote this code? It's so slow. It could be better. And so you kind of got to weigh the two things. What we initially talked about, Joe, is maintainability versus performance. And I've always said I'm the performance guy. I say 51% is typically performance, 49% maintainability. I switch my mind from time to time at a corporation like Office Depot, where you're working with hundreds of other developers. Maintainability does kind of take precedence. But when you're trying to scrape every microsecond out that you can, it's a big deal. So yeah, coming into any new company, any new code base, obviously you got to learn the code, which can take a month, can take years, can take forever, depending on the size of it. And you really just got to know your tools. And I'd say I'm a big Google fanboy, and Google has pretty much, they've done everything for us as far as the Chrome browser, all the tools within it. They've created the performance timeline, created lighthouse audits. With the click of a button, it can tell you where your faults are on your website, on your application. And so just knowing these little tricks from, that they provided, that's a great start. That's what I tell, anybody I'm teaching on how to tune up their performance and, squeeze those milliseconds out. Other things is I'm a fundamentalist. I'm mainly a JavaScript developer, but I've done everything from C, C++, Java, and full stack, everything. But I'm pretty much JavaScript guy now. And in JavaScript, there's so much going on, as you guys have talked about in the past, and so many frameworks. And it blows my mind, the fact that we still have 75% of websites on jQuery. And yet not one of these people using jQuery has actually opened up jQuery.js. They don't know how it works, how the sizzle engine behind the selection works. And, that was a big pain point for me at several companies, trying to, really get them to understand what's happening behind the scenes. And I think that's a good topic right there, is just, understand what's really going on with the JavaScript engine, how it's interpreting it, how it's and how you can make it better from there.
All right. So you said a couple of interesting things, but before we move on, does anybody else want to jump in with what their sort of own definitions of performance tuning, or what performance tuning really means to them?
I have a kind of a good story. When I was in college, we had a programmer from USPS come in, so from the Postal Service, and they do image recognition on handwriting recognition on the different letters. And he had a good example of performance tuning. They had a system that was written in C, and it was complete spaghetti code, a complete mess. And they needed to shave off 300 milliseconds from this algorithm. And it took them 4 months to just fully optimize this algorithm and, do performance tuning on it. And they saved the 300 milliseconds. But it was amazing how in a system like that, 300 milliseconds, most people don't think anything of that. But in certain domains, I think 300 milliseconds is forever. So I think performance tuning, not something that every developer is going to have to deal with, but in specific cases, I think it's something that's it's kind of an interesting problem. So that's the example that I always go back to.
And actually, back in my college days, a bigger example, I don't know if you call this performance tuning, but it was early 2000s. So general purpose GPU programming was rather new, what we kind of call machine learning and all this TensorFlow stuff, what it's wrapped around now, all the GPU stuff. So we had similar cases where we had all this C code or MATLAB code, and it would take us literally a week to run a vision algorithm. We had to rent out one of the computer labs, run it on 30 computers, and it would take 7 days for an algorithm to run on a 30-second video. So we found that was a problem, and the head guy, the guy in charge, said, "Hey, let's try this new GPU stuff. Let's do it in parallel." And sure enough, I got to be part of that project, and it was literally thousands of times faster. So what took 7 weeks took 7 hours maybe or less. And that was pretty incredible. And 300 milliseconds is quite noticeable. There's so many studies on this, the Doherty threshold, which I learned in that show, Halt and Catch Fire. I don't know if you guys are familiar. They say that 400 milliseconds is the threshold that any end user can actually notice. So if you're above that, then it is noticeable to the user. And this was back in the late 70s, early 80s. The number still stands for that threshold, but today it's a lot smaller. You can notice, any great developer can notice 50 milliseconds, 100 milliseconds. Even a great user that's going on a shopping experience on their mobile phone, one website works faster than the other, they're going to probably buy more products on the site that works faster.
Yeah, there were some interesting studies that Amazon did about artificially delaying things and seeing the correlation between that and sales, right?
Absolutely. I've been to Google I/O twice now. I went this 2016, 2018, and they're great at showing all the different pictures of, 200 milliseconds made our conversion rate 50% better, or whatever the case may be. And they have all these case studies on this, and it's mind-blowing how 100 milliseconds can just change your company, literally. So when we're talking about something as common as a JSON file that you pull in for configuration stuff, if you cut that JSON file in half, it's too big, you can find a way to make it smaller, make that request a lot smaller, then you can see your conversion rates go up, or you can see your web page actually effectively go faster. To do that, you need tools, though. You have to have proper benchmarking. And like I said, Chrome does a great job, but also in your code. One thing we do here at Playwire, we just started, was actually having our own benchmarking suite, I'll say, where we just set up some simple console.time functions in our JavaScript code. And we started from here to there. So a common one would be, okay, when we started right off the bat, when the JavaScript's put on the page and when the DOM content is ready, we mark that and we send it off to our, S3, our data collection, and later we can query that. And as our product goes along and we do more releases, we can go back and check, hey, how fast did we get? Did we get any faster with this? And we have benchmarks along the way to actually see, hey, we saved 50 milliseconds overall across thousands of websites.
I think another thing in this space too is this idea of like it gets exponentially harder. I was watching a talk with Ken Beck actually yesterday, and he was talking about this idea of like, to get something like 80% of the way, if, in this case, we're talking about speed, it might take a certain amount of effort, but then to get to like 98% efficiency, it's like exponentially harder. And then from 98 to 99%, it's like even harder. So shaving off those last couple milliseconds, I think it's interesting how it gets exponentially harder in a lot of cases. It could be easy to shave off 20 milliseconds, but then that last 1 or 2 milliseconds is like way harder. So I think that's another interesting problem in this space, is that kind of exponential difficulty curve.
I have to totally agree. And you got to say, hey, is that valuable enough for your team to work on? If it takes that much time to shave that 1 millisecond, maybe you should work on something else that is a little more fruitful.
So some of the stuff that you mentioned kind of earlier on was sort of the trade-off between maintainability, performance tuning. So there's a couple of aspects I'd like to talk about there. First off, let's just talk about maintainability versus performance, right? You said that is a trade-off. So how does that work? How is maintainability and performance actually a trade-off?
Well, the biggest example I have is I worked at Office Depot for about 3.5 years. Our entire UI team for e-commerce was, I would say, 50 UI developers. So we had to get all of us in a room different times and come up with certain standards and try and push our ideas on people. At the time, everybody was extremely comfortable with jQuery, for instance. I was one of the biggest lovers of jQuery when it first came out. It made coding easy. Everybody loves it. And, you can make an Ajax call with saying .ajax. That's great. But then the world kind of changed when we went to JavaScript, 2015, right? ES5, where now JavaScript and the ECMA crew came out and they said, hey, jQuery is doing all this. Let's do everything that they're doing, but make it native and make it better, and actually not have the end user have to understand the nuances of these selectors and the things that are slowing it down. For instance, people don't understand adding that $sign and the 2 parentheses around something. That's a function call. That function call goes deep into several other function calls. Whereas if we are doing that natively, just in JavaScript, it's one single function call. It's native. And you can test those. You can put the console time or do the jsperf.com is one of the most common ways to analyze how fast something's going, and just see which one's faster. Every time native JavaScript's gonna beat any library. As far as maintainability, you just have to be on the same page. Here just recently we started with Prettier, the framework library, whatever you want to call it. As well as ESLint, having that in place and having everybody on the same page with that, because everybody has coding styles. I'm sure everybody knows about the tabs versus spaces and the breakups that have occurred over that, and fights and outrages over something so silly. But things more in depth, occurring to performance, such as what library to use, or if to use a library at all. These things are a little more touchy, and yes, they should be agreed upon, but there should also be, you have to make a use case for it. You have to, prove that what you are doing and what you're saving is saving enough time and making sure your developers understand it enough to be able to code in that certain way, in that certain pattern, get everybody on board. So I'd say that's the trade-off. The biggest trade-off is say, hey, I'm trying to get you off of jQuery, but you don't know the new JavaScript syntax yet. So it's going to take you time to learn that. And it's ever changing as well, just regular JavaScript, the fundamental vanilla JavaScript. But so is that worth our time? You have to calculate that as well.
Yeah, and I think it begins before that too. So I agree. I think that the trade-off begins on what is it that we want to prioritize before I even start writing code, right? So how do I approach this? Do I care more about having my code be really, really performant and really, really clever? Or do I care more about making it readable first? And then later, when we run into those performance issues, then we go and do the performance optimizations. So I think it's more along those lines. So how do I approach this? What is it that is more important to me before I start writing code?
That's a wonderful point. I've struggled with that my whole life. I always want to make everything perfect from the very beginning, my architecture and everything. Whereas not everybody, but a lot of people have told me, get it working first. Get it going. Yes. Have your alpha version out there, get it working, and then we can iterate. And that probably is the better way. I'll be honest. That is the better way. Sometimes, however, you do get stuck if you don't have that great architecture in place. For instance, we just had a huge release here, big change, switching from old JavaScript with var to new JavaScript in Webpack, which and test-driven development. We're doing TDD now here, and that was a big change. And our code base we wanted to convert to Webpack, but it wasn't prepared for test-driven development. So in that sense, we had to do a lot more work than was initially intended to make this huge Webpack change, which would in turn also give us those performance enhancements. In Webpack, I can't emphasize enough how great it is for performance once used right. Dynamic imports is something we got to gauge. Webpack was I used it in the past, but not to the extent that I have this past year. And we actually, with those benchmarks that we did take, we got to see our numbers for our video player be in the up to 10 seconds for the video to load. And we got that down. We cut it by, I want to say 40% at the highest. So, down to about 6 seconds on the really slow web pages that they run on, which is just hugely significant. So, yes, Webpack, dynamic imports, that is also a huge thing to know for performance in general.
All right. What about the rest of the panel? How do you manage maintainability versus performance?
I think for me, one big aspect of that is choosing the right language or choosing the right framework. So, a good example would be like, if you're really concerned with speed, maybe you shouldn't be choosing a language like Java or C#. Choose a language like C or C++. Instead of writing bad Java code without using any design patterns or using any clean code, just trying to get it as fast as possible. Instead, you could use a faster language like C or C++. The code can be cleaner and it's inherently going to be, faster, at least in certain circumstances. So I think a big part of that, like maintainability versus performance, is like just picking the right tool up front, and then you don't have to confront that problem as much. As long as you're using the right tool, I think you can kind of avoid that as much as you possibly can.
Yeah, I think that there's a part of it, when you're on any job, you have to define what good performance looks like. I've worked for a lot of internal business application kind of situations where like shaving off milliseconds really isn't the goal. And so, but it's easy for developers to sort of get lost on that like obsessive track on trying to shave off performance seconds. So I think the team up front needs to talk through like what's an acceptable threshold of performance. And, that just might be things like not having crazy queries that are held in memory for a long time. And then you can sort of kind of like what Mike was saying, you sort of go with the big wins first and knock out like 80% of it just by choosing your stack and agreeing on best practices and things like that. And then you can kind of work your way down to the really minuscule performance stuff that probably only matters for things that are like heavily dynamic UIs on customer products and things like that.
It's a problem with so many variables too. Sorry, go.
I was going to say I am that obsessive performance guy, which does get in the way sometimes. But luckily, we have a nice grace period in our Q4 where we get to refactor, and I get to put my skills to use, because it's one of the reasons I got hired here is being the performance guy. So, but yes, you can get obsessed over it, and you can get obsessed over those milliseconds. And you also have to understand that your JavaScript code isn't always the culprit of your bottlenecks, right? There's so many bottlenecks, and it usually has nothing to do with that. Us switching over from HTTP1 to HTTP2 made way bigger of a difference than us switching if we were to have switched from jQuery to vanilla JavaScript per se. So things like that definitely have to be considered as well, not just your code itself, especially when you're talking on the web.
Yeah, that's true. And we don't get me wrong, we need people who are like you, who are obsessed with performance. But I was just clarifying, because sometimes I imagine we have a lot of beginners who listen to this podcast, or people who are like relatively new, and I know when I was relatively new, I was like, oh, should I be worrying about performance? Should I be like obsessing over like, how do I learn this stuff? And it turned out that like most of the time we had already made those decisions long ago, and it wasn't relevant to the work I was doing. And so I think it's an important part of learning about performance is learning about when to learn about performance and when it actually matters in your project, you know?
Yeah, I agree with that. I was thinking about the same thing. Like, performance is like security. It's one of those things that if you're a beginner, first you need to get working code, right? And then I'd rather have you write maintainable code, clean code after that. And then you worry about security, and then you worry about performance. But then again, it's as I said, too many variables, depends on your use case. Maybe you are in a company where performance is really, really important. So you need the performance guy. You need it. But then the landscape has been changing. Like, I started running a team where we had a data center, and we were running on bare metal. We moved to, virtual machines. Now we have containers and stuff. But a lot of people are in a place where they can go hybrid or maybe full on the cloud. So a lot of the performance issues that we had before, we can just throw money at it now. We can have an elastic cloud, and we just say, hey, I know that it happens a couple of hours a day, and those just spin up 10 other containers, and that's it, and just throw a little money at it, and you solve that problem, and then you concentrate on the other stuff until you get to the point where you need the performance guy, and then you need to squeeze every ounce of performance out of it. So many variables in this equation, but I'm not saying it's not important. I just say that, like in my case, because the question was, how do you handle it? In my case, it's a little later down the list. It comes after security. Like, it would be first security.
I'm going to 100% agree with you. As a code mentor, I'm at codementor.io website. My mentees, they're beginners. Start them from the bottom to get them up. You got to get that working web page working first. It's going to be ugly, but just get it working, get it up and going. You don't even know much about performance at all, because that's just going to confuse you. So just knowing the fundamentals of web development in general, how it works, what the client side is versus server side, all of that stuff does trump performance in the end, because in the end you will have a working product if you work hard enough at it. And like you said, at the end you can also go back, refactor, and either get that performance guy or learn on your own how to do so. So yes, I totally agree that is probably the last step, and that's probably why they did bring me in here. Actually, now that you bring it up.
Well, in the podcast, we usually focus on aspects of learning. So let's kind of switch a little bit. Now that we've talked a lot about performance and its place, let's talk about learning performance tuning. What are some great ways to learn performance tuning? Let's say that I've decided either I need to for a job function, or I'm just interested in the topic. Where do I start? What do I start doing? And we could kind of sort of keep it focused a little bit on the web, but I think we could also talk about subjects bigger than the web. But what do I do? And I decide I want to learn to performance tune.
Well, speaking, I do mostly web stuff. And if there's a function that I want to know if it works faster this way or this way, jsperf.com, you can just set up your test there real quick, and it puts a timer on. Or I typically just type in jsperf, jQuery.ajax versus fetch, two functions that do the same exact thing in two different ways. And it'll iterate it thousands of times and tell you which one's faster. And it'll say fetch is 99% faster. So it's like, oh, okay, there's my answer. Other than that, using actual tools to be able to do this on your own, the number one tool that I advise anybody I talk to that's just been wonderful to us is the Google Chrome Dev Tools. They have the timeline involved in there, the performance timeline. And so it's baked in. You just inspect your element, and it's up there on a tab. It says performance or timeline, one of the two. And you can record, and you can see everything that's going on. It's a little overwhelming at first. It shows you a bunch of colors and a bunch of stuff you're not aware of, but they have a great help section on what all that means. And usually when you see red usually means bad. And, digging deeper into that, you can actually find out how to fix that red and to make sure that that red goes away. And as that red goes away, you can watch your website get faster. The other tool I just love in Chrome DevTools is the one I mentioned earlier, Lighthouse, which is their auditing tool, which just pretty much tells you what to fix. You go in there, you push the button, say, what's wrong with my website? And they can give you a score and tell you exactly what to fix. Maybe your picture is too big. Maybe you're not on HTTP 2 when you should be, stuff like this.
Okay, so those are a lot of good tools to use in your performance tuning, but I just go in there, I see that some stuff is slow, but I'm not really sure how to fix it. Where do I go to start learning better ways to write my code or address the issues that I find in my code?
I always start with Google. They seem to be the ones that run everything. They created the JavaScript engine and the Chrome itself. So I can't tell you how important and how life-changing Google I/O was for me. And I found out, they record most of the sessions online anyway. So most of their sessions, just if you do a Chrome I/O performance, web performance lookup, you will be mind blown. You have to pause several times to take notes at all the different things you can do. They just came out with something new called the Performance Observer, with this new observer kind of movement that JavaScript's been doing. And then just how to use these tools, because some of them, like I said, the timeline can be kind of cumbersome and takes a lot of time to kind of understand. But I always start with Google. They know how their engine works, their JavaScript engine, because they built it. So they can explain how, maybe the concept of tree shaking, which is common in a few languages, if I'm not mistaken. I think Java does tree shaking as well. Getting rid of variables that aren't used anymore, so that there's not just stuck in there and taking up room, and you're not able to do all your garbage collection, hence eventually slowing down your page and hence maybe crashing your page eventually.
So Tommy, I actually have a quick question kind of related to this. How much of being the performance guy do you think is an art versus a science? Like, is this something that could be taught? Like, could you sit someone down for 2 hours and teach them how to do this? Or is it something that requires like a kind of more of a level of wisdom? Like, you'd have to kind of be doing it for like a couple of years. So is it more of an art or a science, do you think?
I can't call myself an artist in that way. No, I do think the art comes from the more maintainable code. What I do is, a lot of the times it's not much fun looking through those timelines and finding those bottlenecks. So yes, but it can absolutely be taught. The guys here that I work with, we have a small team, probably about 10 developers on our team. And, anything I know or learn along the way, I try and teach them. It can definitely be taught. The guys to follow, all Google guys that I know, Paul Irish, he's in charge of the web dev tools. Paul Lewis is also big into CSS, which is one thing that never gets talked about as far as performance, although we know it can hurt or help performance, but it's hard to gauge. That's one of those things that can make or break you, but it's very hard to do a timeline on. We do have tools for that now, though, and it's extremely Googleable and extremely taught. You can teach it. It won't take you 10,000 hours to become an expert.
There are a few really good courses on front-end masters. While we're on the subject of educational resources, John Cooperman has a course on Chrome developer tools. Steve Kinney has a course on JavaScript performance. And then Sean Larkin, of course, web performance with Webpack. So those are all really good resources. And then a guy named Umar Hansa made a course called Modern Dev Tools that is pretty neat. It's fairly short. It's only like 18, 20 videos, but goes through and does like real examples of performance debugging and things like that. So I'll throw up links for all those.
I am familiar with him. I subscribe to him. He's a good guy. He's always ahead of the curve. I'm not sure if he's close with the guys at Google or whatever, but he knows all the tips before I do. I recommend subscribing to his newsletter. He'll send out the performance stuff before I even know about it. It's in Chrome Canary the day of. So that's a great one. Another great tip that I would suggest if you are trying to learn how to get better performance out of your applications in general, just a silly trick that anybody should know is Google Alerts. I have my Google Alerts set up for daily anything new that comes to the web that's JavaScript or JavaScript performance. It gets sent to my email to add to my list of other hundreds of alerts that I have in there. But that's just a great little tip to learn every new thing that's coming out, that's news.
All right. So I think it's also interesting to talk about the various different kinds of performance issues that you will encounter as a developer. I think most people are just assuming, hey, performance is I'm writing a piece of JavaScript and that piece of JavaScript is slow. You sort of alluded to this a little bit earlier, Tommy, but what are the various kinds of performance issues that people can encounter when they are writing web applications?
That's right. We always want to blame it on our JavaScript and think that it is our JavaScript that's slow. And in fact, JavaScript is really fast. Even if you do intend to code it slow, it's so fast now and so efficient. So a lot of the times it's not necessarily your JavaScript. A lot of times it's something in between. Typically those handshakes, making requests to other services, any API calls. So for our instance here at Playwire, our video player has to call an ad server. Calling that ad server, it has to do all this stuff on the back end and take its time. So our video player is showing with a little loading spinner, and the user's waiting and waiting, and we're like scratching our head over here as developers, like, what's going on? As our video player, the non-tech guys are saying, oh, our video player is slow, when in fact, it's not the video player that's slow. The video player is booted up. It's the fact that our endpoint, who we're trying to talk to, is taking a while to respond. So I think it is important to note that, the APIs, the services that you are calling, your application is using, whether it be any geolocation stuff or what's my IP or any basic API that you're making calls to, making sure you find the fastest one. Even databases, certain database services can be faster than others. And that's another part that I'll talk to about and praise the dev tools is your network tab. That network tab shows you a beautiful waterfall of how long everything takes. So you can pretty much look through that waterfall and say, first of all, I don't know what this request is. Let me find out what that is. And there's a nice little tip in there that Umar actually taught me. If you hold shift and hover that request, it will show you where that request came from and show you every other request spawned from it as well. But that's a great place to look as well. If something's hanging up in there and taking so long, that's a great place to start is inside your network tabs to see, hey, first of all, what's being called? Am I calling a font that's taking forever? Google Fonts is something that a lot of people don't understand, but they use really quickly since it's so easy. Even in WordPress, Google Fonts usually hangs up quite often if not done in the right way. Other optimizations too, small things like pictures and numerous types of network requests. So yes, we're talking about performance. I was starting in performance in web, but it's a lot of things. There's a lot of things to it. Anything web-based that you're trying to talk to or get information out of.
So I think another thing that's really important is being able to use the tools correctly. So for example, if you're using a framework, it's using that framework in such a way that it is performant, especially if you're doing things on the front end, like animations or displaying large amounts of data. You want to make sure that the tools that you are using, you're using them effectively.
I couldn't agree more. We have, it's so easy for us to get our design team to give us an SVG, which is a bunch of characters of code for a simple image, which is better than an image, but we can do better now with CSS. You can do, I don't know if you guys have been on CodePen lately and get lost in there with some of the CSS that these people get crazy with, but my goodness, you can create any shape or any image with just pure CSS. And a lot of times that's going to be more performant than an SVG and certainly better than an uncompressed image. So that's a great point.
All right. So kind of want to start heading towards the wrap-up phase. We talked about some utility or some resources for learning performance tuning, but what about practicing performance tuning? Let's say that you're really interested in it, but you want to practice it. If you don't have an adequate production system to utilize or practice certain aspects, or what are other ways to practicing performance tuning so that you can know that you're really figuring it out?
It all starts with, to me, with the console.time and console.timeend. If you can slap that around any function and play with that function, get your end result. So console.time will start your timer. and console.timeEnd, you want to put that after your function. And whenever the function is done executing, the console.timeEnd will give you a millisecond, or hopefully not, but seconds of how long that took to execute. I think that is the number one way to start. And if you just start with the console.times around certain functions might be problematic, then and then maybe optimize. What was the example we had, Joe? I think it was our conversation got started with the .for each on an array.
Yep.
So if you have an array .for each and you put a console.time tag above and below it, you can see how long that took. And then maybe use a native for loop that we're all used to seeing, see which one runs faster. And if that seems that it is, only a couple milliseconds, a few milliseconds, and you're on a large team, then maybe it's not worth it. Maybe those 2 milliseconds are not worth it because you're working with a big team and you want your code to be nice and elegant and, a one-liner instead of our old school for loop. Whereas if you want to squeeze every millisecond out, every microsecond out, you will want to pick the lowest time that console.time spits out every time. Google also has a couple extra performance tools inside. Yep, there it is. If you just, inside Google Dev Tools, if you just start typing performance inside the console, there are a ton of things in here, performance timing. They even have stuff for CSS, which has been, like I said, one of the most difficult things to gauge for performance testing. And now we have the tools for that. We can see, why is this image flickering, or why is it coming in pixel by pixel and it shouldn't be? And there's a lot of very easy answers to that. Just ask Google, actually. But understanding that, and that's where I would start, which is using console time around any functionality you have any issues with, you think might be slowing you down. And then after that, like I said, it's a lot of times it's not understanding your the libraries you're working with, such as jQuery. jQuery's it's gotten great over the years. I can't believe it's still around, honestly, but just knowing the tools that you are using, know how they are written. Don't be scared to go into jQuery.js, the uncompressed version. They add comments in there and tell you exactly what it does. So they tell you, hey, this is the more effective way of how to use this. No developer likes, or I can speak for myself, I don't like reading documentation all day to understand all the things we have to understand to be a great developer. But sometimes it is worth it. Any other thoughts from the panel?
Another thing you can do too is just go find slow websites online and just take a look at why they're slow. If there's a website that you're visiting and you're like, wow, this page is taking forever to load, use those tools, those dev tools or the Google tools, and just figure out what's happening. Is it an image that's taking forever to load? Is it a font? Is there something, does it seem like it's something with the code? Just kind of playing detective and going in and seeing, because all that stuff is public for any website that you're on, if you're using Chrome or whatever. So I think that's another good way, is just playing detective on slow websites that you find online.
I think you nailed that, Mike. And back to those Google I/O videos I encourage people to watch. I was lucky enough to run into Paul Irish, and the fanboy that I am, he's kind of the creator of Chrome Developer Tools, or parts of it anyway. I had to stop and take a picture with him. But if you can look up any of his talks, Paul Irish, Google I/O, he does exactly that. He will show you a slow running web page intentionally and show you some new JavaScript thing that came out, or maybe a new CSS attribute that came out, property that came out, and he'll show you side by side, oh, we just did this one little one-liner and look how much faster it's loading. And he goes, step by step, how to make this faster. So yes, I totally agree. Playing detective is definitely the best way. Awesome. Well, we usually like to finish up by asking our panel to each sort of chip in one thing that they know about, that if they had a friend who didn't know about that thing, they would tell that friend about that thing, or want their friend to know about that thing. So we'll have Tommy kind of go last. If the rest of the panel is ready, is anybody ready to go first?
I can go. So I actually missed the last 2 podcast recordings because I was on vacation last week. Went on a cruise in the Caribbean, and we went to St. Thomas, was one of the islands we went to in the U.S. Virgin Islands. It was awesome, super beautiful. So if you're ever down in that area, St. Thomas is a really cool place to check out.
Awesome. Luis, you up?
I have a book by Martin Fowler, Refactoring. The second version is in JavaScript. So the examples are now in JavaScript. So if you did not read the old one from like 18 years ago, now's a good time. Go and visit that book, Refactoring by Martin Fowler.
Sweet. Sam, what about you?
I just discovered this Mac tool called Keyboard Maestro, and it's crazy because you can basically automate your computer to do anything. So like if you want, you could set it up to like, as soon as you join your coffee shop Wi-Fi, it hides all of your applications except Visual Studio Code and mutes your sound. And so it's really awesome. So I've been experimenting with that for like screencasting and things like that.
Wow.
Keyboard Maestro.
Keyboard Maestro, that's awesome.
Yeah.
All right. I'll go next. So this last weekend, I went to a board game convention, which is just as awesome as it sounds. If you've never heard of the concept of a board game convention, you should totally check it out. But while I was there, I played a really fun board game called Zombicide. And one of the more recent ones that came out there's all these different heroes you can play where you go through and try to clear out a big field of zombies with your little. It's a board game, but it's really fun, and you can play it with any size group up to like even probably 10 people, but plays really well up to 6. We had a really big blast playing it. But they have like Stranger Things characters. If you're into Stranger Things, you can play the Stranger Things characters. They've reimagined them for zombie killers in the Dark Ages fighting zombie orcs, and and a Wonder Woman character and a Princess Leia and a Snape. It's super fun. So if you're looking for a really, really interesting board game, it's definitely unique, but I highly recommend it. Zombicide. Tommy, what about you?
I also was on vacation 2 weeks ago at the Dominican Republic. And what I learned today that I'll share from Luis, since we had a pack of about 19 gringos with us and not one of us spoke Spanish, you can say vina for any word as a wild card. Is that correct? Vina?
Vaina.
I wish you would have told me that before. And it's been a pleasure. This is my first podcast showing, so I do appreciate the honor.
Awesome. Well, thanks for spending time with us, Tommy. It was a great conversation. We really enjoyed it. And thanks again to the panel for showing up. And we'll see you all the next episode of the DevEd podcast.
Bye.
Bye, everyone.
Vina.
Adios.